Hello and welcome today to multiplying powers with the same base. All right, so yesterday we spent a little bit of time learning about zero and negative exponents and how we handle those. Today we're going to look at what happens when we multiply powers that have the same base. So the primary thing we have to make sure of is that the base of our power situation is the same, because this only works when the base is the same. So let's take a look here today. Key important note is when multiplying powers with the same base, you add the exponents. Now, why does this work? Well, for example, if I say to you a to the 5th power times a to the 3rd power. First of all, my first check is, do I have the same base? Yes, they are both a. So really what this means is I'm taking a times a times a times a times a, that's a to the 5th, and then I'm multiplying that by a times a times a. Now, if you look at this, how many a's do we have listed? Well, 5 and 3 more. That's 8 a's. So that's really like saying a to the 8th power. So what did we do just there? We took our powers, which were 5 plus 3. We added them together to get this a to the 8th power. So that's why it works. It works with anything. If I would have said 2 squared plus 2 squared, we would have 2 times 2 times 2 times 2. Well, how many times are we multiplying that base? 4 times. So a squared times, or excuse me, 2 squared times 2 squared is 2 to the 4th power. All right, so let's try a few. Because it gets a little more interesting here, because now we can start adding negative exponents, we can have numbers, we can have letters, and the important part is, again, just putting together the things that have the same base. So for this first problem here, our directions for all of these are actually simplify the expression. So I see that I've got 3 as my base, so I know 3 is the base, and it's 4 plus 2 plus 3. So 4 plus 2 is 6, plus 3 is 9. So my answer would be 3 to the 9th power. And at this stage, that's enough. Unless they ask us to actually calculate 3 to the 9th power, which is 3 times itself 9 times, we're good with that. All right, for this next one, we are going to, oh, my dog is deciding he would like to check out the microphone here, but he got bored with it quickly. All right, so next we see 13 is our base. So once again, I'm going to take a look at this. And since 13 is my base, I see a 5 plus a negative 7 plus 4. So now my usual rules apply. 5 plus negative 7, opposite signs, so I subtract. Negative 2. Negative 2 plus 4 is 2. Oh, there we go. So the answer to that problem is 13 squared. And again, unless they tell me I need to actually take 13 times 13, I have found my final answer. All right, next problem. I know it's your favorite. We have fractions. But we're not going to let that throw us off. The beautiful part about this is, if we can find beauty in it, which of course I can as a math geek, I already have a common denominator. So when I look at this 1/5 and 3/5, I'm not too alarmed because I know how to handle that. They both have the same base, 2, and I know I'm going to take 1/5 plus 3/5. Since it has the same denominator, all I have to do is add the numerators. 1 plus 3 is 4, so it's 2 to the 4/5 power. And at this stage, we're not ready to kind of talk about what that actually looks like. So we'll come back to that. We'll eventually learn what to do with it. But right now, what we need to know is that's 2 to the 4/5 power. All right, this next one combines a lot of stuff. So let's take a look at what we've got. First of all, you should see that you've got numbers here in the front of letters. All right, so what that tells me, excuse me, what that tells me is I'm going to have to take 5 times, it never likes it when I make my dots apparently, 5 times -3. Okay, so I've got 5 times -3. That's one part. I'm breaking it into its pieces. Then over here, I've got b to the 3rd and b to the -6th. So I'm simply going to take b to the 3rd times b to the -6th. So again, when I break these pieces down, this is going to become 5 times -3, which is -15. I apologize, my dog is in the background here playing with a toy and growling at it at the same time. And over here, we've got b to the 3rd times b to the -6. Well, 3 plus -6 is -3. All right. So this is not quite our final answer. The reason we can't call this our final answer is this piece right here. We don't like to see our negatives left, backtrack that, guys. We don't like to see our exponents left negative, not the other way around. But I'm okay with this as a negative because it is just simply an integer. There's no exponent there. So we're okay leaving that part negative, but this, we don't like the -3. So if you recall from yesterday, when we're going to have to cross the line and change the sign because we need to make that exponent that's negative positive. So we end up having a -15 and the b cubed drops to our denominator. And that right there, until they tell me the value of b, I have solved it as far as I can. Sometimes we're asked to find the area of figures. And again, we are now using some algebraic expressions for the lengths of the sides. So first of all, for number 5, I have to recognize that this is a parallelogram. And a parallelogram, we're going to treat much like we would a rectangle or a square, in that the equation is base times height. So for this particular problem, we're going to take 3n squared and we're going to multiply it by 6n plus 5. All right, so right away here, the first thing I hope you are noticing is that we've got a situation where we're going to have to deal with the distributive property. So I'm going to take the 3 times the 6, and when I take 3 times 6, I get 18, and then n squared times n. Well, this n over here, we have to imagine that that n is to the power of 1. So anytime you see a variable without an actual exponent on it, we know the exponent is 1. So 2 plus 1 is 3, so 6n to the 3rd power. And then 3 times 5 is 15. But we can't forget we still have that n squared. All right, now this part gets tricky, and this is where students will potentially make some mistakes, and that is I now have an addition sign in between here. This is no longer multiplication. So I can't put those n cubes and those n squareds together. Instead, now I need to think back to when we talked about combining like terms. N cubed and n squared are not like terms. Therefore, I have simplified this as much as possible. Now, had the n squared been an n cubed, then I could put that together. All right, so number 6 here, 3z to the 4th power. I hope right away you all see that this is really just a square. It's got these line points here, which indicate, hey, whatever I tell you one side is, that's what all the sides are. And we know to find the area of a square, we are simply going to multiply the two sides. Whoops, I did it again. I tried to make a multiplication symbol, the dot. It just doesn't like that. All right, so if I break this into pieces, I see that I've got this 3 and this 3, so I know I'm going to multiply those integer values. And then I've got a z to the 4th power and a z to the 4th power. So 3 times 3 is 9. Z to the 4th times z to the 4th, I'm going to take 4 plus 4 is 8. So my final answer to this one would be 9z to the 8th power. I know it is now time, the moment you have all been waiting for. I know you get very excited to do these problems. So here are 3 that I would like you to try. Now make sure you take a look at problem number 3. What I want you to notice on this one is this right here. What I'm asking you to do is to tell me m to what power times m to the negative 4th would give me m to the negative 9th. So if you would go ahead and work on those, and we will talk when you come back to class. Thanks. Have a great day.